good.
You see it?
Yep, we do.
Okay, great.
All right. Thanks, everyone who's looking online, who's joined us online. If you did request to be pulled into the Hangout and haven't received an invite yet, please just be patient. We're sending those out as we can. So while that is happening, our special guest, Uri, is going to be presenting to us today about Dataflow. And rather than me give an inadequate introduction that doesn't quite capture the essence of what's going on, I'm just going to hand it off to our guest. And thank you very much, Uri, for coming on and presenting with us this month for this meeting.
Well, it's a long trip to Dallas Fort Worth for me, so it's worth it. If my time is worth something here, I'm talking about commuting from my office here to your place. Should I actually start with the talk, or you want to wait till people join in?
Let me see if I can't pull in some more people. Unfortunately, it's a slow process sometimes.
Well, I'm patient. I blocked out 2 hours of time here. It's a learning thing. We got to do this kind of overhead stuff before 8 o'clock in the future.
We've done this in the past, but I'm using a computer that I haven't used previously.
Oh, excuses. I'm joking. Just remember, I have a very bad sense of humor.
It's giving me all kinds of problems too. I got a hyperactive trackpad.
Wait till you see the last slide. It's a killer.
Okay, sending out the invites now.
Okay.
Also, he's got the function key where I have the control key. That makes things really exciting.
I'm not going to go ranting about where the control key should be, but IBM screwed the universe.
Well, they apparently screwed me.
The control key was the left of A for decades. All the VT100 terminals, all those similar type things. And IBM said, well, we want to make the PC just like a typewriter so secretaries will be comfortable. So they put a caps lock next to A. But on a computer, you don't need a caps lock. On an old typewriter, you did because it was hard to actually shift up the carriage. And so IBM basically broke a lot of pinkies ever since then by putting the control key where my caps lock is located. So whenever I have a non-Sun keyboard, I always swap caps lock and control using Xmodmap. Little tidbit for anybody listening here. Control is to the left of A. Anywhere else is wrong. And you can't argue it. Just because IBM made a stupid mistake doesn't mean it's right.
Okay, well, I've sent out the invites. Let me see. Are you able to see the screen up there? I'll move the hangout screen up there.
So I thought we might need to.
Is it over here?
Yeah.
All right.
Okay, how many people do you think have signed in? I want to know if my worldwide audience is.
Oh, right now we've got 4 people watching so far on the live stream, and we've got 4 people here in the room, and I've sent out some invites, so everybody else is, it's on them to hop into the discussion or not. But you've got an audience here, and with that, I'd like to kick things off.
Okay, well, let's go.
Go ahead and share your screen.
It is being recorded.
It is being recorded. This is live.
I can't say flubbergaster then. I said flubbergaster. I shouldn't say that. Okay.
Words you can't say.
Yeah. Okay, folks. Well, welcome to all you people in Dallas, Fort Worth, and online, and out in the universe, and later on YouTube. So, Dataflow. Before we do that, I want to bring out the inner child in you guys. So, make some noise or whatever, say something. If you play with one of these building toys, and I'm sure you're very familiar with most of them. Lincoln Logs, good old childhood favorite. Any Lincoln Log users out there? Tinker Toys, discs and...
Charlie, I use Lincoln Logs a lot.
Okay, cool. And
we
Tinker Toys, discs and discs and dowels. A little Tinker Toy tidbit for you. Anybody ever heard of the TV show The Prisoner with Patrick McGowan from the 60s? They used Tinker Toys in a couple of scenes as sort of odd decorations and things on set. Very bizarre. They used Tinker Toys. Kenner. I use Kenner a bit. A little boring because all you can do is build up bricky-looking apartment buildings. Connects I never used, but I saw it around, so I figured I'd put it up here. Some people used it.
We're not actually seeing the screen though.
Oh, what's going on here? Did I not share it?
It was shared, but now we're just getting a black.
Oh, let me try and share it again then. I don't know what to do here with the share. Oh, that's annoying.
It's okay if you come up here. I'll share the power out.
I'm starting another screen share. That work?
There we go. Connects.
Okay, let me go back a little bit. You see the Kenner?
Kenner, yep.
Okay, and Tinker Toys, and back in Lincoln Logs. Okay, good. Okay. Erector sets. Any of you guys ever seen or play with an erector set? I had this very red steel case with 3 merged sets from relatives, and my brothers and I played with this a lot. You guys see this motor? This is a motor here. It's an AC motor with a high-speed shaft off the back and a reduction gear drive with 2 forward and reverse speeds here. Does your car have 2 reverse speeds? We built an elevator to the top of a bunk bed, a giant Ferris wheel, a car that would only go as far as the extension cord would allow it, all kinds of neat things. Erector sets are very, very cool. Nuts and bolts, tiny little nuts and bolts and steel girders and plates. Very interesting stuff. And of course, Lego, which I never really played with a lot, but of course, some of you guys are still playing with it. At YAPC, when I gave this talk, it was the biggest cheer was for Lego by far. Okay, so you remember the fun with these toys? You're only limited by your imagination, or the toys can be building a lot of different things. Many possible projects from the same set of parts. You could build a tall thing, a round thing. You could build with Lego. You could do all kinds of stuff. And those toys are way more fun than most coding projects. I think you can agree with that one. Now, what do these toys have in common? That's the important thing. They all have a very important thing or two in common. The most important thing was any part can connect with any other part. That way, you have a lot of flexibility in how you're building things. Lego parts snap together. Any erector set girder or steel piece can be screwed onto another piece or using things. They're all interconnected. And simple toy parts, these are very simple parts, can build a very complex thing. So you are the architect, the designer, and the builder when you're playing with these toys. Now here's an important point too. The architecture design of what you're doing, you're building, is external to the parts. The parts don't inherently say, I must be connected only to that part no matter what. That's not the case. You choose what's going on. So which part you connect to which part is your choice, your design. Okay? You're not limited by the way the parts are built. So let's make programming fun again. Advertisement. Do you ever use file Slurp? You can hire its author, me. Advertisement over. So Dataflow is a way to build applications the way you build with these toys. It's a very, very different view. It's not even a paradigm shift. It's a meta paradigm shift. It's way up there. You'll see. So a data flow application is a set of interconnected nodes. Nodes will go into more detail. So a node is a class or an instance object. This is true in Perl or in any other language too. Nodes are given unique addresses, like email addresses or IP addresses. Within your application environment, each node has a unique address. Nodes can send data via those addresses. There are no direct calls between nodes. Okay? So you have a mesh or a network of nodes that are connected by data flows. They're not connected by program calls. Any node can send data to any other node. It's up to you to control and configure what's going on. That is called a universal API, one of the principal points behind Dataflow. Universal API is a very, very powerful concept, and you've used it many times, but really nobody's ever called it this. It's a term I came up with, and I think it's appropriate. Same as with interconnected toy parts. Any part can connect to any other part. You can snap any Lego part to any Lego part as long as it's got the right size buttons, those little knob things on top. But not all possible connections make sense. You know, you can connect things up randomly in Lego, and you're not going to get anywhere. You connect things up in a plan, you build your spaceship, your car, whatever you're building. So here's a very well-known API, Universal API. Everyone uses this all the time. The shell tools, standard I/O, and pipes. Stuff comes out, standard out, goes through a pipe, goes into standard in. You make a pipeline of multiple processes in a row. That's Universal API. Do you realize how many, I can't even say thousands or even hundreds of thousands, how many millions of programs have been written that use standard I/O and can be working with a pipe and a shell? It's just such a concept that we don't even realize that's a brilliant idea. Well, we're going to do this in the same way, but at a higher level. The pipes are limited because of what they're limited by the shell. So a Dataflow application has an external configuration. This is like the plan or the architecture of your toy building. It's not coding. A configuration loads and initializes nodes with addresses and their arguments. So configuration is just data. It's not coding. This is an important point too. In all application systems out there, when you're connecting things together, you must write code to connect things together. You call this, and that calls that, and then you take the data from that, and you do that, and you call that. You don't do that in Dataflow. So configuration, because it's data, can be generated, pushed or pulled, and dynamically changed. You can change a Dataflow application while it's running. Think about that. You could add nodes, you can change addresses, you could do a lot of things to it. You could change where data is going. We'll talk about that a little bit later. Based on whatever you want, the phase of the moon, you know, you're crazy, you're overloaded, you've got to add features, whatever it is, you can change things. Most applications can't handle that kind of thing. So the configuration is the architecture done by the intelligent designer, which is you. It's not done in the code. You have control over things. You don't have to worry about where the code is going. Now, data flow that's going between nodes is just data. That's not objects. You do not send objects back and forth. You send data. I want to differentiate data from objects. People think that everything has to be an object. That's wrong. I learned object orientation code from Barbara Liskov, one of the pioneers of this. And the important thing is data was organized and collected into a structure or something which you can then pass around as a single entity rather than scalar, single variables, globals all over the place, which was the traditional way of programming. That was the big thing. Everything else you'd learn about objects, everything, you know, encapsulation, inheritance, all the fancier things you see these days, all that is bells and whistles on just collecting data together. Data flows are unidirectional. But you can make a bidirectional one just by making two unidirectional data flows in opposite directions. There's not an issue of being unidirectional. But each individual flow is unidirectional. Basically, a sender sends data to a receiver. That's a single data flow. Data flows can be streaming or packeted data. So they can be like a text stream or a binary stream, or they could be a chunk. Here's a request with all the arguments in the request, or here's some results coming back from somewhere else in a chunk. However you want to define your boundaries. It's no different than using TCP in that sense, in that TCP can be streaming text or it could be chunk data with some protocol. Here's a neat feature. You ever want to log something in a system and in a particular location, in a particular place, you have to write code, change it, build it, do all the kind of stuff and do that. With Dataflow, you can log anything, anywhere, anytime, even while it's running. You can tap into a data flow via its address to log it. So if you know an address of something, you can add a feature. You can add, say, okay, log this data flow at this address. The data flow log can be sent anywhere. It can be filtered for parsing, whatever, or stored. That's all up to you. But you have access to any data flow you want in the system to do anything you want with it. You have total control. You don't have to, instrument something with logging. You don't have to write logging modules. You don't have to do all this kind of stuff. Turn logging on, turn logging off, do this thing. You could just turn it off at runtime, and it's designated there. If you don't need it, it's not there. So logs can be used for debugging, tracing what's going on, replay, which is kind of cool. You could basically replay the log of data into the system and simulate what's going on, and for testing. Again, you can replay existing logs or one you want to create into a system for testing. Who has never heard of the Goldilocks story? Well, I hope you all heard about it, because the Goldilocks principle is another key thing. Data flow nodes should not be too big or too small or too hot or too cold or too soft or too hard or any of those kinds of things. They need to be sized just right, just like Goldilocks. Nodes should be simple modules that do one thing and do it well. Focus on the function you're doing. Do it, get data in, do your work, get the hell out. That's all you should be doing in data flow modules. You look at CPAN and modules out there just do way, way, way too much. They're not a system anymore. They're like, they're not a module anymore. They're like a full subsystem. It's crazy. So remember this line. Complexity arises from layers of simplicity. You do not need to write complex things off the bat. You write a bunch of simple things, connect them together, and you can get a lot of complexity and power out of that. But you have to be disciplined. Dataflow gives you easier unit and integration testing. Like a Dataflow node can test other nodes. You can write a special node just for testing that'll test out your node that you want to test. So a test configuration, I mentioned before, it can load a unit or an integrated part of an application. You can load any subsection of your application you want as long as you know what kind of data it's going in and going out. Imagine that. You can load up 20%, 30%, 70%, 100%, one unit, anything. You don't have to worry about what boundary you're using. Oh, here's an interesting boundary. We'll start working at that location. That's a big win. So addresses are set in a testing configuration to allow data flows to be sent and received to the unit or section under test. So they're not going out to the real world. They think they are, but they're actually going to your test nodes. And that test node's sending in, replayed or fake data and looking at the results and saying, this is what I'm expecting when I send data to you. I'm getting the data back, blah, 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 test okay. And those, you can write all those things using the test more protocols and that kind of stuff. Language independence. Now, I'm a Perl guy and so are you, but this is kind of cool. You can write processes in other languages and still interconnect them. You don't have to worry about which particular language you're using. This library is written in another language. You wrap it in something like in Dataflow. You can now talk to that library from another language on another Dataflow process. The only thing you need to do is have a common encoding on the wire, the socket connection, and for example, JSON is perfectly fine. It supports multiple encodings. This is a single little thing to choose at the last second. Oh, here's a big rule. Plugins are not allowed. Plugins are never needed in Dataflow. Well, they aren't really needed. See, Dataflow, every node is already a plugin. Since everything's dynamic and controlled by addresses, you can plug any node you want anywhere, and it doesn't. You don't need to write a special plugin layer. The Universal API takes care of that. That's another win for the Universal API. Have you ever wanted to take some data that's going somewhere and tap into it, or move it elsewhere, or broadcast it, or take data from several places and funnel them into one place? With Dataflow, this is all easy. You can switch and multiplex data flows so trivially. So you can do publish, subscribe, you can funnel, broadcast, push-pull, RPC, almost any kind of communication paradigm. Matter of fact, not almost any kind of communication paradigm you could think about can be done with Dataflow. You can't say that for any other communication mechanisms out there because they're limited in what they can do. Dataflow can emulate any of these right off the bat. Have you used the Perl jobs list, anybody? I'm sure some of you got jobs through it. I created it. Looking for work myself. Another advertisement. See, a slightly larger font than the small print there. Any questions so far? I haven't heard any. I'm going a little faster than I expected.
I don't know. We had you on mute. We're off mute now. We got 3 people in the room.
Okay. Any online people have questions?
I have a question. How do you put this? Hi, it's Boris. How do you put this into an existing project? I mean,
well,
this is it's a good model if you start something from scratch.
Well, it's a good question, and I think you can do things like, for example, let's say you have a library that does something. You could wrap it in a Dataflow node, make it accessible, and then you can write a socket layer using the Dataflow system that talks as a client or server to something else and make it accessible remotely that way. It's not something you want to just plug into existing code base directly. That's not going to work. I agree with you there. But it's not something you can't. You have to isolate. That's something you can't add to a system as long as you put it in the right place. That makes sense?
I'll have a related question when you get further into your talk.
Well, ask me now if you want.
Well, see, I have a language environment that just dishes off threads to me when I need them. So I just say, give me a thread, and I get the thread. Right. And I don't need to look in the nitty-gritty details how these threads are managed and allocated, because I just write the user code. So let's say I wanted to, we're going to talk in your talk about, not using thread switching so much, but using like waiting for I/O. It's not really clear to me how to integrate this into the architecture, so I don't have to do anything by hand, that it's part of the architecture.
Okay. Well, it so happens I created something about 15 years ago, way before it was ever done elsewhere, I could tell, that integrates event loops and kernel threads. If you want me to talk about that, I will. There is a Perl module that does that, but not as well as I would like it to be done. It's called IO::AIO. Look at that if you want. But the secret of that is very interesting. It uses a pipe, but within the same process. That's a very unusual thing. Most pipes are used between processes, and you open up handles, you dupe handles, and you connect up things like that way, like shell tools do it with pipes there. But what you do is you create a pipe, and on the event loop side, you put a reader event looking for reading, and on the other side of the pipe, you fork off a bunch of threads. You can do it on demand, one pipe per thread, or a bunch of threads reading from one pipe. It's a different style. The threads wait to read a single pointer, C pointer, to a data structure. When on the event loop side you want to do something that's going to be blocking, a C call that's blocking, You take a data structure, you fill it in, whatever structure you want, it's a custom structure. You then write the address of that structure down that pipe. When one of the threads sees it, it wakes up and reads the pointer, then executes the work. And then takes another structure or fills in parts of that structure, whatever, and it writes that pointer back up the pipe. Now the event loop side sees that and wakes up and opens up and reads that pointer and then passes that data structure back to the main event loop. So now you have an ability of having an event loop manage all your asynchronous operations and have your threads handle all your blocking kernel operations. And they're totally synchronized by using the pipe.
Okay, so I guess my question would be about the side where I write the receiving side of the...
By the way, this is not Dataflow I'm talking about. I'm talking about a way of integrating event loops, asynchronous behavior
It wasn't
with
part of your
synchronous
article.
threads.
That's why I asked. It was part of your Dataflow article.
Sorry?
It was part of your Dataflow article. That's why I asked this question.
Right. That's in the article. Right.
Right.
I didn't bring it in the slideshow because I didn't want to put too much in the slides. So the point is that that's how you integrate synchronous and asynchronous behavior. And it's very efficient because you're not blocking anything and you're not stopping anything from working. I did this. By the way, I'm going to tell you what. One second. Let me tell you what I did this for. There's a company called Northern Light that, when its heyday, when Alta Vista was the king, was the number 2 or 3 web crawler search engine in the country. And I wrote the crawler for them. It was a single C process with 2,000 parallel fetches going on using an event loop, but it did reverse DNS lookup by this technique I was talking about, because that's a blocking operation using a library. And it did reverse DNS lookup as needed.
It's time for us to go. I know you don't want to stop, but come on.
Okay. Wait. What was this? Hello?
Please ignore me. I'm sorry. I'm trying to mute my microphone.
Okay. I'm going to continue on the talk, okay?
Yeah, I'm sorry about that.
Did that help you, Boris?
If you have some question, I'll just ask you privately or later.
Oh, yeah, you ask me privately if you want to get something that deep privately. My contact is the end of the slides.
All right.
Okay. So here's the first loss of data flow. You actually have to think differently, and I put differently there because Apple doesn't know grammar. A mental shift similar to learning event loops and GUI callbacks. There are some people who just had trouble learning. You'll see with the next slide. Have you ever heard of newbie whine? Who is calling my code? Where's this coming from? Where's my main loop? They just did not understand how an event loop worked. And I saw this years and years ago when people were learning these things. So it's a paradigm shift in your brain how you do things. You just don't call down, you send data. There is overhead in sending data. But the speed up of distributed applications makes up for that. And the trade-off of the overhead for the increase in development speed and lower support needs. Dataflow modules tend to be simpler and need less maintenance over the time because you're not constantly glomming in new features like you're not supposed to. Loss number 3, the core infrastructure, managing the data flows and the addresses and all those things has to be coded up. But I have a working prototype in about 10K lines of Perl, which have many added features, including socket management, process management, multiplexing, timers, cron, all kinds of things. So if you ever want to talk about an actual system, we could talk about that as well. The loss number 4, this is something that does have to be done. We need to build a library of application nodes. Login, verification, filtering this, accessing the database, doing all kinds of things like that. That has to be written for your application. But the Dataflow nodes are easier to write and test, and they're more reusable. And you write some of these modules you see out there, and they just are hardwired to a particular paradigm, to a particular set of modules. You can't just plug them in somewhere else. So consider that an investment in the future. Boris, you're talking about, you can't just do this with an existing application. That's partly true, but that's why I'm talking about the future here. And has a major return on investment Because once you get your libraries done and once you get the systems going, creating a new application is so easy. You may have to write a few new modules and stuff, but you just connect things together just like the toys. Here's the wins. A lot of wins. Universal API. External configuration. Big win. Highly isolated code. You know, we always talk about keeping your code away from other people. Well, this way, it's totally isolated. Code does not call other code. It calls data flows. And it means you're full isolation. You don't have to worry about action at a distance, all kinds of things. You have a very shallow call stack. You ever tried debugging something which is 15, 20 calls down and your problem is way at the top and tracing all that? It's a pain in the you-know-what. So you have a shallow call stack. Data comes in, you do some work, you send data out, you're done. It's shallow. No dependency hell. A related thing from the shallow call stack, you're not loading up half a CPAN when you load up a module or loading up a system. You just load up what you need and that's it. The modules tend not to load up other modules. Your configuration loads the modules. So you don't have to worry about a module depending on something else. You just use it as it is. Log anything anywhere. Explained that before. Big win. Dynamic configuration. Take any of your applications, try and change it while it's running. Ha, ha, ha. You can't do it. With Dataflow, you can actually change things while it's running. Just add things, change addresses, add nodes, redirect things, change switching maps, all kinds of stuff. Easier testing because you can isolate nodes and modules so well. It's easy to test them and integration tests, things like that. We covered that before. You could switching and multiplexing data flows. You can't do that with other code. A lot of wins here. Local versus remote. This is a big thing. You know, there's systems out there which do message passing and process, but you have to write a different API and we want to go to a different process. Or even Perl 6. Perl 6 does not have a good way to communicate between remote nodes. They have local stuff with promises and all that asynchronous behavior. It's really cool stuff. But they do not have a remote one. If they use Dataflow, they get that win for both local and remote. Important change. And it's way more fun. Okay, so if you're interested in Dataflow, you can contact me here. If you have a Dataflow project, contact me today. And if you have funding for a Dataflow project, contact me yesterday. Finally, this is something I wrote for YAPC, and Larry likes it, and Larry's wife, Gloria, said she wished Larry had written it. So Larry said with a lisp, shh, awk and grep are the basic sounds I make when I see too much data flow.
Yeah.
That was my punishing line there. Okay, that's the end of my talk. We're open for more Q&A now, other than the ones that will take an hour to answer. Plenty of time here. I didn't know what my speed would be like. Was I too fast or too slow, folks?
I think it's good. There was one question brought in, and that was on these addresses. Are they IP addresses plus port? That is to say, is it using TCP for each node?
No, 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 no. It's not. They're addresses within the Dataflow system. They're just strings, just like email addresses. There's TCP underneath it all when you're connecting between processes, but that's invisible to the Dataflow layer. You have a special module node that connects processes together and transfers data back and forth. Okay, but once the data crosses the pipe and is in the process, then it's regular data flow again. So the only time you have to worry about that is when the actual socket-to-socket connection being transferred. So the TCP part is part of the configuration of those particular socket nodes, but once they're set up, it's bidirectional data over those sockets, and anything from one process goes over that same socket to anything in the other process, and the data contains addresses. That actually is a structured thing, and it's not necessarily an object, and it could be an object, doesn't have to be an object, but the data inside there is whatever you want. It's a kind of a carrier of data. That explain a little bit?
I pinged him in the chat.
Okay. Let me see if I can find chat here myself. And
well, I think that was not in the group chat.
oh, okay. Sorry. Hey, Boris, are you there?
He's muted.
Okay. Okay. I feel like we've met somewhere, and I don't know where or what. And any other questions out there?
Hey, I have a question.
Sure.
I apologize for the background noise. My question is, well, I actually have two. How do you handle error correction when communication gets broken on the network? Question one. And question two is, how do you safely handle shared memory space when you're passing pointer addresses back and forth between pipes?
Okay. Let's answer the second one first because it's easier. There's no issues with that because when you're doing that, you're only doing that within a single process. Okay, so there's no issue with the shared memory space. Either the thread is working on that memory space or the main event loop is working on that memory space. The pipe synchronizes between the two of them automatically. Only when one of them has the pointer can it work on the memory space. So there's never an issue with clobbering shared memory. It's not shared memory, it's just one global memory space. We're not talking about shared memory between threads and things like that. We're talking passing a pointer to a memory location, and that's never passed to another process. That's only when you want to integrate kernel threads within a single C process or Perl process. Okay? That help you there? Hello?
Yes, it does.
Okay. Okay, I just want to make sure I could finish the question, and then we're done with that. Now, recovery from errors. That's a very good question, and it's a very difficult problem. I don't have a direct answer for it. There are message passing systems out there which guarantee message delivery. They're all commercial, MSMQ, MQ series, TIBCO, Sonic, all these kinds of things. They all guarantee delivery because they are client to server to client. Your client program sends a message, and only after the system receives the message, stores in a database basically, sends back an acknowledgement, then you know you can go ahead and that message is going to be delivered, and it'll retry and it'll handle communication errors and things like that. That is a phenomenal amount of work and overhead to guarantee message delivery, which is why those are all commercial systems. Even the free ones that are out there, RabbitMQ, things like that, aren't that perfect in that world. Okay, so either you know your system is robust and you can handle it yourself. If a socket goes down, you reconnect, things like that, or you have to write in a whole layer of guaranteed delivery, which breaks the whole paradigm of dynamic behavior, because now you have a very, very locking database kind of thing to deal with. It can be in a separate process and make it a little easier, but it means you still can't just send a message and go away. You have to send the message and wait until the acknowledgement happens that message is going to be delivered. So it's up to you to decide what do you want. Do you want phenomenal overhead or flexibility? It's a choice. There's a lot of systems that will do that guaranteed delivery. I am not saying I think it's not important enough. For the kind of applications you're running, you can just restart the socket and reconnect up. If you want to, you can make an end-to-end handshake if you want, just like with a UDP type protocol. That would work too. You send data, you get an acknowledgement from the far side, and then you know that you're done. You can send more data, or you can go on to the next step. That's a different way of looking at it. That's an end-to-end handshake. And that's not hard to write, but it requires you to deal with state machines and the whole thing about maintaining state between the 2 points. That's what TCP does for you. TCP is basically,
Yeah, I was going to say, this kind of feels like TCP, what we're talking about.
Yeah, it is TCP. The connections between processes are going to be TCP. The question is, if a TCP socket breaks, which happens, how do you recover from that? Well, if you just want to restart the socket, you can do that. But if it broke in the middle of the socket of a data flow, then you got to decide: do you want to worry about that? Do you want to continue? Do you want to, build a handshake end to end? A lot of different things you can do. You look at most systems, though, they don't have recovery from that either. A typical Apache application, if their socket dies, or your browser dies, the socket dies, and you get a reset. Happens all the time. You just reconnect and try again. So there's that possibility as well.
So maybe
that helpful?
We're not in the business. Yeah. So maybe we're not in the business of guaranteed message delivery, but what about? So we're not doing error correction. What about error detection?
Well,
I'm sorry for belaboring the point.
I trust TCP enough that I don't worry about that. It's got error detection built in. If you want, again, you could add your own error correcting or error checking code on the data. That's not hard to do. Just do some sort of checksum type thing. Encryption is possible. Instead of using IO socket, I use IO socket SSL. It's a plug and drop in thing. And that way you have secure sockets, and there's no change to the API or anything like that. That help?
Yeah, that does. It gives me an idea for a project I'm working on.
Okay, well, if you need any help in a project, I'm available. Another plug for myself. Any other questions? I'll be glad to answer more of them. Is Apache Airflow a Dataflow API? I don't know. Okay, I've never heard of that project, and it could be. There are other Dataflow things out there. I know that. They're not always called Dataflow. And you have to look at it and see whether it's really asynchronous, whether it really handles the two primary things in the Dataflow of all else is universal API and external configuration. Everything else falls out of that. If you don't have those two things, that's not what I would call Dataflow. Okay? That was Tony Esposito. Tony, you used to be a goalie for the Chicago Blackhawks, if I recall. Very long time ago.
His avatar is the 1960s Batman.
Okay. Well, I'm serious. There was a pair of brothers in the NHL back in the 70s, Tony and Phil Esposito. Phil Esposito was a Boston Bruin, and Tony, I think, was a goalie for Chicago. I don't know why I know that shit. Oops. I said I wouldn't curse. Okay, any other questions?
I don't know. Oh, we got one in the room here.
Okay.
The slides or something like them available. I was held up and got here about 20 minutes in. I was wondering if there's a way I could go back over the first.
Sure. So yeah. So the question was, are the slides available online?
I haven't put them there. I was just editing them today. I was editing them like an hour before the show, and I have not done that. I will put them up. I mean, you know what? Here, I'll copy them up right now, and I'll tell you. I can paste the URL in the group chat.
All right, and I can attach it in the Google Plus.
Give me a couple of minutes, about a minute or so here. I just gotta go to my place and find out where I'm doing it. Okay.
And I can talk about that too. So this recording, the YouTube Live, that gets converted in about 30 minutes after we end. It's usually available just on YouTube to watch this whole thing again.
So I can come back 30 minutes after we end and ask a question.
Yes. And then.
Would that be useful? Would I get an answer useful?
So if you ask the question in the comments below the YouTube video, we'll get notified, and if it's something we can answer, we will. If it's something Uri needs to answer, we'll make sure and send him the link and let him know that you asked the question. So we'll close the loop.
Okay, it's uploading right now. I'll have to give you the URL. Move your ass. Come on. This ODP format is pretty bulky. I'm only at 62%. That's LibreOffice Impress. I'm not very impressed by it, but it's better than handwriting slides. So that was painful.
I don't remember you having a lot of images in there.
I wrote a lot of the stuff over yesterday and today. The images were stuff I got from when I was doing my lightning talk at YAPSI, Orlando. I just didn't have time to create any images. Okay, the upload is done. Come on, return my shell.
So an interesting tangent here is I'm trying to remember the Microsoft Office PowerPoint. So PowerPoint versus the OpenOffice or LibreOffice. One of the interesting things about that is that the open document format will store the original images in the file, whereas PowerPoint converts everything as you bring it in, and
there's the URL. It should be good.
Recompresses it. Okay. Let me grab this file.
Let me know if that works for you.
Well, it's not letting me swipe it and copy it. That's handy.
Well, that's a different issue.
Yeah.
I can't fix that.
I think I could probably figure out how to fix that.
Okay.
Ba-bum. So anyway, if you drag a really large photo over into Impress, then it stores the really large photo. It doesn't resample it or anything.
Oh, okay.
So that can be bad, right?
Yeah, I have those 5 photographs in the beginning of the different toys. But even that, they shouldn't be that big. They're just JPEGs I stole from the web. No copyright notices any of the pictures. Yes, I just Googled for those toys and took a picture I liked. You know, Google has a zillion images of those things.
Dataflow _ talk.
.odp, yeah.
Good. Come on.
I could probably also export that as an HTML thing. I've done that, but I assume anybody here can read OpenOffice.
That's the other thing. Are you using LibreOffice or OpenOffice?
Libre.
Yeah, Libre's better. Yeah.
My wife was helping me do a review earlier of the text, just clean up things, little grammar things, and she saw stdio. She says, "What's that?" I said, "That's standard IO." So you have to spell that out? No, that's how it's spelled. I said, everyone will understand what standard IO is I'm talking to. It's just like it's normal. She couldn't handle that weird abbreviation.
I'm thinking this would probably be good to put on SlideShare, or at least I want to toss that idea out. It's nice because, if somebody Googles Dataflow, they'll be able to find your slides and look at them.
Okay. Where is that, or what is that?
Just SlideShare. Just Google SlideShare, and you can upload your presentation.
It'll take an OpenOffice, LibreOffice ODP?
If it doesn't, I'd be flabbergasted. In which case, you can export it as PPTX and upload it if you wanted to.
Yeah, I mean, I could export it as HTML too.
It just has for example, if you were to Google OpenShift right now, you would get results from SlideShare. If you were to Google OpenShift how-to, OpenShift tutorial, you've got presentations like that, and it's a good place to publish your stuff.
Yeah.
Who runs that SlideShare? I mean, it sounds like the Google thing, or not?
It's actually, I think LinkedIn bought them recently, so Microsoft maybe.
Oh God.
Yeah.
I'm really thinking about closing my LinkedIn membership soon.
Same.
Red Hat's got a lot of good stuff on there on SlideShare.
I'm not talking about LinkedIn being bought by Microsoft. I just can't stand the idea. I mean, now that I'm using Google Hangouts, I don't need to use Skype anymore, which everyone's telling me has gone downhill since you know who bought them.
Uri,
Yes.
So real quick, that I typed in that link and I'm getting a Hurricane Electric file not found.
Okay. Let me try it myself.
I pasted it back in. Make sure I typed it right.
Oh, when I found. Okay, I mean, give me another minute. I may have done something wrong. It's more likely than anything else I did it wrong.
So I'll switch the video over. So I guess you're looking at me. I am.
Oh, okay. Wait 1 second, please.
Yeah.
Oh, God. I put it in the wrong place. I gotta find it.
Let's see. There we are.
Okay, I put it in the wrong place. My mistake. I have some sim links and things out there. I did not do the right thing, and I can't figure out what I did wrong. So. I don't even know where. Oh, here we go. No, that's the wrong thing.
Yeah, we're here. I looked up Dataflow on the Meta CPAN and I pasted that link in there.
Oh, my copy never seemed to work. Okay, I'm going to do it again.
Okay. Built on top of Moose.
Oh, that means it's overhead crazy.
A little bit.
You know, when I get people who give me sample code that they've written in Moose, I always tell them, where's the code that does the work? Because 90% of the code I see then is just declarations. It's like declare, 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 and it's like, where's the work? It's not coding anymore. I'm not a big fan of these systems that they claim they solve a problem, but the problem they want to solve isn't the problem they are solving. Meaning that, I'll give you an example. Look at Dancer and Modulicious and all those types of things, even Catalyst. Guess what they really do? They just map a URL to a call. That's about all they do. There's maybe a lot of bells and whistles on there. That's the fundamental thing they do. They don't address the whole asynchronous nature, distributed nature of things. Or, there's another issue which I didn't address here, which is asynchronous flow control. Let's say you have a request coming in, and you have to go to 3 different back ends, each with a different speed, and you want to get them all at the same, whenever they're ready, and collect them all, and then continue on where you're going. That's an asynchronous behavior, but you're in a synchronous piece of logic. That's a non-trivial thing to do. Perl 6 addresses that with promises and the way they can do things, but only within a single process. So I have a plan and a design that's actually in the prototype of the Dataflow system I wrote that actually does this correctly. It's a mini language that is a synchronous logical flow that supports asynchronous behavior. Okay. Oh, damn it. At least Hurricane Lecture doesn't kill the URL when I typo it.
We
You
can
go
always,
some.
yeah, paste it in afterwards.
Okay, it's there. It's now where I told it would be. Okay.
Okay.
Sorry about that, guys. The URL yeah, the URL I gave you should work now.
Yeah, 5.5
Okay.
meg, not too bad.
Yeah, sorry about that. Okay, let me get back to the Hangout page here.
So the Dataflow module by Russo, that's not what
I don't know anything about that module.
Okay.
And there's no way you can do data flow in a single module. It's impossible. It's just too much stuff. I mean, my system is 10K lines of code, of which hundreds and hundreds of lines are involved in the core level of message passing, address management, node management, all those types of things. There's lots of bells and whistles, but I'd say at least 1,000 lines of code is in that. It's in multiple modules. I just can't imagine one module doing it. That also means it breaks the Goldilocks principle, which is a very important thing in general, not even for data flow. I mean, you look at certain systems out there, and they include half a CPAN. They are thousands of lines long in each module. You can't make heads or tails out of it.
I have another question. At what granularity do you want this to be used? I mean, not at every function call. You want
no. It's at an object level. Okay. I'm trying to give you an example. Okay, let's look at a process module which I've created. So the process module can take commands to fork off a process. Okay. It can take a command to clone itself and dynamically fork off a process. That way you can have a farm. It can take data in either packetized or stream data, and it'll send it down the socket to the process, the child process. Okay? So it basically has about 5 or 6 different kinds of commands it can take. So when you're writing a module, you create places where the data flow is going to come in. You can write a universal one, like a wildcard, that takes all data flows coming in, or you can write ones that are custom to a particular type of data. Data can be given an attribute and a type. This is text. This is commonly it'll be text, or it could be login information or query information, whatever you want to call it. And the address that you're setting it to could be part of that, and that could be it could determine, or the type can determine which method gets called in that process, in that object. But you don't want to have 30 methods in a single node. Then you're doing too many different things. You see, you have to come up with the right balance. There may be methods to actually send the data to do work. Some methods change some options and features. Some methods do some major command changes. So you can have a bunch of them, but if you have 50 methods or 50 different things, then you're doing too much stuff already, and you should have broken up into different things. That's just a question of just software organization. I'm very big on just the whole Goldilocks principle. Make things the right size. Don't make things infinitely big and just keep glomming stuff into them. I use stuff there instead of the other word. I'm being clean here. Tommy has a little girl who's going to listen to this later. Hi, Tommy's daughter.
Yeah.
Boris, did I help you there?
Yeah, thanks, yeah.
Okay. Boris, you sound very interested in this thing. I'd love to talk to you more. We could talk here too, but I don't want to bore everyone else with our personal conversation here. If you want to reach me, you have my phone number and address on the slides.
Okay, thanks.
No, I don't mind answering some questions here. Just let other unless nobody else has any other questions.
Got one more question in the room here.
Okay, fire away.
Is there something that's been architected and developed with data flow and shift and has gained visible use somewhere in the world that we might have heard of or might be able to see?
Yeah. So the question was, has it been deployed on any system that we know?
My stuff or other stuff?
The data flow.
Well, data flow is a concept. Data flow is a concept that's been around for 40 years. if you Google for this name, Arvind, just that name. He's a professor at MIT who's been big into data flow. I learned hardware data flow from him in school 40 years ago, or 35 years ago. That's his full name, Arvind. And his biography talks about data flow projects and things. I was interviewing a company in Boston, Boston area, that is actually implementing a data flow system in JavaScript. Unfortunately, they didn't hire me. They thought my article was brilliant, but they thought my fact I was a Perl guy and not a JavaScript guy was an issue. So they are implementing a data flow system. I discussed this in depth with them, what they're doing, and it's data flow. They're calling it a little different thing. They're doing a little bit different the way things are done, but overall it's the same kind of architecture. So why they chose JavaScript, beyond me. There are projects out there. There are not that many in Perl. You're not going to find them advertised because that's a different way of thinking. I mean, look at all the things you have to change. You have to change how you write your modules, how you think about building your applications. You have to write a whole new library of things. You have to write infrastructure. This is a barrier. Oh, I'll just use this framework, Ruby on Rails, and add my crap to it and just use that thing. And that's what people are doing. They take the easy way out. And this is not the easy way out in the short run, but it's 10 times easier in the long run. So that's the whole thing. If you write your set of modules and things and you develop a set of application tools, you can then create new applications so well. There's a guy who signed on named Harry Wozniak. I don't know if he signed on to the group chat. I'm sure he's listening. He left group chat, so I don't know, whatever. He contacted me when he heard about the article, and he and I are going to work on improving my prototype, and we came up with an interesting application, a to-do list application that'll run on any system. Central server that'll run on mobile phones and on web pages and things. So we're going to start developing that. Any of you guys want to help out with that project, it'd be a good way to get to learn the system, and maybe we can get some actual real service out there and people might buy it, because I would use a good to-do service. I even came up with a name for it today. I haven't, TUDU.
And that's not taken?
Well, I don't know if it's taken, but we could TUDU dot something or other. That's the point is that it's like, I thought of a cool domain name for that, one of those misspelling domain names everyone likes.
Okay, so currently you've got the prototype for the data flow system. And then the to-do
I did use it a bunch of years ago in a real project, but their funding disappeared and they never deployed it. But a well-known Perl person and I were working this project, and we were extremely underpaid, working with a couple of real idiot jerks, and they just were pain in the ass. But we did get a live the distributed crawler, specialized crawler, only going to certain news sites, running under this system, and it worked pretty well. It had like 7 or 8 processes, including several that were database dedicated processes, and including an index engine and things like that. So it was a pretty nice system. It was ran under the software. But that was a few years ago.
Cool. Does that answer the question?
Pretty much, yeah.
Okay. All right. Any other questions, Ben?
Is there a particular type of development project that might not be suitable for this particular paradigm, or that you would?
Well, yeah, I hear what you're saying. There's plenty of things that aren't suitable. Okay.
Can you restate the question then?
Yeah, the question was, are there any paradigms or project types that are not suitable? Well, I mean, my most recent job, I did some straight CGI web reports. Here's the query coming in, get some data out of the database, print a table. That's not appropriate for this. I mean, that's a dinky project. We're talking about things that are running long time, back-end, distributed, network, those types of applications. There's plenty of applications that are not those things. I wouldn't use this in a compiler. I wouldn't use this thing as in a straight web application. I wouldn't use this as a, whatever. There's a lot of things, It all depends on, you need something that's dynamic, networked, distributed, where the asynchronous, where these behaviors and these services are valuable, as opposed to as opposed to a monolithic, a single function program like a web application or something like that. Not a simple web application, CGI thing. If it's more a question of, you have to ask that question, you don't know the answer. You're not going to know whether to use it or not. It should be very obvious. This is suitable. This is not suitable. I'm not trying to insult you. It's just more a case of,
Sure.
the answer is in the question. Make any sense?
I sit corrected.
Yes, he got it. Have you thought about calling Delta
Delta?
Airlines?
Okay. Why?
Oh, they had a 6-hour.
Oh, yeah. Yes. Okay. Well, I'll tell you this, guys. There's a system out there called Sabre. Have you ever heard of Sabre?
Indeed, we have.
It's airline reservation system.
They're here in Dallas, right
Yeah.
down the road.
And it was written back in the late 60s, 70s, and it was one of the first distributed transactional systems out there. And it still works. It's still clunkier than hell to use. The pro guy who owns a travel agency, David Adler, maybe you guys know him, DHA, and he knows how to code into Sabre. The codes are weird, but it's still used by all the airlines. So yeah, that would be a great system to write under the Dataflow, but a few $1 billion a few $1 billion in funding and a lot of strings pulled and a lot of but Sabre is still the same system running in these old mainframes. Sabre is very impressive when you realize what it's doing. And I mean, they wrote that, and they still can't write anything for the VA to talk two different computers together.
Oh my gosh! Yeah.
Veterans Administration, these two large computer systems, and they spend billions, and they can't get them to talk to each other. I'm thinking, I'll buy you a few tin cans and strings. It'll cost you only $1 million.
Yeah, I had personal experience with that with my dad.
Oh, really?
Yeah.
Oh, your dad had VA needs?
Yeah, and he traveled up from Amarillo, Texas to Dallas, Texas, and he needed to get basically a prescription for insulin, and they wanted him to fill out the entire dossier before they would write him a script.
Oh man!
It took 4 hours. It was insane.
That's crazy.
Yeah. So.
Well, I'm ashamed. I'm ashamed that our industry can do some stupid stuff like that. I mean, seriously. I mean, they spent $1 billion, $2 billion on trying to get those systems to talk to each other. I'm thinking, what idiots are out there? Mind you, the systems are probably crappy, crazy, archaic, heads up their butts kind of database structures. We know that. But you can always convert something to something and shove it into the other system. ETL is, it's like, I've done a ton of ETL, not that scale, but give me the $1 billion. I'll hire a few good people. We'll get it done. They basically, it was like Accenture, one of those large consulting firms that knows how to deal with government contracts, like the guys who did the Obamacare.
Yeah.
The National Obamacare was done by a company called CGI. That's their name. The Canadian, and they did Massachusetts one, which they threw them out. They were sued by other people. They just wrote a crappy system. And it's not a difficult system. It's like, fill in your information on your thing. Here are the different programs you could be in. We're not talking rocket science here. And they did a crappy job that they had to bring in these gurus from outside the world. And, we sped this up by just ripping this shit out or doing this kind of thing. And that whole process that happened, that 6 months of really smart people working and throwing out the bad code. It's like a lot of idiots out there.
They know how to write a great RFC.
Yeah, it's they had the RFC that nobody wanted to bid on it except this company. The problem is bidding for government contracts is an art in itself.
Right. Yeah.
Just the bidding. and they won't talk to you and me. Not that we are bidding on government. I could hire 50 people to do the job, but they wouldn't talk to a guy like me. I have no idea how to possibly get my foot into a government project. Yet I could do a million times better job. So that's the whole. That's not getting into politics. You're in Texas. You got enough trouble.
Yeah, we got enough trouble. That's for sure.
I mean, it's like, boy, I won't say anything. I can't say anything because I have no idea what you guys are like, and you may just shoot me. Yeah, it's being recorded, and you guys have carry law.
Yeah.
You could shoot me over the net.
Nobody has been shot with that or over that yet, but it's a matter of time, right?
I love that they opened up the law 50 years to the day of the guy killing the people in the University of Texas.
Yeah.
The guy with the tower.
Poetic, ironic, take your pick.
Yeah, that's strange. Okay, I'm willing to answer any more questions. We can talk offline later with people. What do you guys think? Give me some feedback. Anybody want to hire me?
Wish I could. I'm just a guy.
Yeah, that's what I am too.
Anything over here? Comments? Interesting. All right. Yeah, I don't think I caught on until the questions afterwards about the scale and the scope of the system that you built.
Okay.
It's like I went to CPAN. I was looking for a module, right? So I don't know. Maybe touch on that earlier in the thing, but.
Okay. It's not an easy talk to give because I don't know what I'm missing in terms of, what people need to hear, fill in the gaps, things like that. I know this stuff so intimately that explaining it and what's important and what's not important is a tricky proposition. So this was an interesting exercise for me in general. Okay, any other comments or questions?
I just have a general comment that this is pretty much a very hot topic because half the people are doing Node.js programming, and the other half people in the world are doing Ruby on Rails programming, and they are very two different style of programming, and they don't know how to talk to each other. Entire companies drop their Ruby on Rails, go to Node.js because they can't handle the load. But then Node.js looks like spaghetti code. It's called callback hell.
Boris, you mentioned spaghetti code. Here's a little quiz question I give. It's a bonus question for a quiz I give out, and I like this question. What is the opposite of spaghetti code? It's a trick question. Think out of the box.
The opposite of spaghetti code.
Yeah.
Grapes.
What?
Grapes.
Grapes?
Yeah. Grapes are hierarchical.
Grapes as in the fruit grapes?
Yeah,
Yeah, in a bunch.
The way they grow.
Oh, like in a bunch. No, wrong answer.
Yeah, which direction to go?
It's a trick question.
It's all spaghetti code, but.
No. There is an opposite answer. Opposite spaghetti code. I'll start singing Jeopardy theme.
Can I buy a hint?
The answer is clued in the question.
I figured you would say that.
Well, it is. Think out of the box.
Outside of the box of spaghetti. No laugh. Come on. No, I think you got it stumped.
Okay, lasagna design. Layers. It's another pasta.
Yeah.
It has the perfect visual for Opposite spaghetti code.
Okay, well, I like my answer as well. So.
Oh. Yeah, but I'm the judge. You're wrong. Okay. Feels like we're done?
I think so.
Okay. Boris, if you want to contact me offline sometime, I'd be glad to talk to you more. Be a lot more effective than this Hangout stuff.
Okay, all right, I'll let you know.
And other people that are out there too. Okay. Thanks, guys. I appreciate the offer, and you know, spread the word out. I could do this talk again with other groups so they can watch this one on YouTube and all that kind of thing.
And so, yeah, I want to thank you for doing it. Definitely.
You're welcome. Send me the URL to YouTube when it's done.
Will do.
And then I could publicize that. Bye, guys. I'm going to disconnect here now somehow. What do I do? Yeah. Way up there. Oh, hang up the phone.
Yep.
Bye.
Bye. So, Boris, you're still on. I will say grapes, seeds are recursive. So, I'm with you. All right.
Structured programming.
Yeah. So the only other thing, I think this is pretty much going to be around Dataflow. Is there any other general Perl questions we want to do online? We go ahead and end the recording otherwise and do something local. Okay, we'll go ahead and end the recording, I guess, for this time. Going once, going twice. Can't count my fingers. All right. Thanks, Butch. And yeah, and we'll post out the URL when it's all done. Join us next month when we're going to talk a little bit about OpenShift and Docker and how you can use that to do some interesting, Perl containers. And that's it. That's all I know. Bye.